Welcome to this video lecture on the subject transmission lines and antennas. So in this lecture we are going to discuss about general theory of transmission lines. So first of all, what is the need for line parameters? So transmission lines parameters are used to design a transmission line and understand the properties of a transmission line. So generally transmission line, it is used to transmit a electrical signal through lines or cables. So it consists of a distributed elements. So distributed elements are the resistance, capacitance, inductance. So these are distributed along the transmission line. Basic transmission line parameters are resistance, capacitance, inductance and conductance. So let's see it one by one. So first of all, resistance. So this parameter of any transmission line rely on the cross-sectional area of a conducting material. So these are distributed parameter networks. It means its parameter are distributed uniformly along the entire length. So it is represented by R and its unit is ohms per unit length of the line. So since it is equally distributed uniformly, so it is taken as ohms per unit length of the line, and this resistance value can be calculated using rho L by A, where rho is the conductivity of the material and L is the length of the transmission line, A is the cross-sectional area of the line. And capacitance, a transmission line is composed of two parallel conducting wire separated by a dielectric material. So it behaves like a parallel plate capacitor. So this capacitance is distributed uniformly over the length. So it is measured in farads per unit length of the transmission line. Activity. So it is based on the calendar. Inductance. When current flows through a conductor, it generates a magnetic field perpendicular to the direction of the electric field. As the magnetic field varies, electromagnetic flux gets generated in the line. So this EMF now flows in opposite direction with the current flowing through the device, which is known as the inductance value. Its value depends on the current flow through the conductor. So it is unit is Henry per unit length of the conductor. Next parameter is conductance. Here the two parallel conductors are separated by dielectric medium, but it is not a perfect insulator. So some current flows through the dielectric. So this current is called as the leakage current, and it is responsible for leakage conductance through a transmission line. It basically present between conducting wires and is represented by G. So its unit is mho per unit length of the conductor. So relation to other parameters, so transmission line series impedance, so Z equal to R plus J omega L, where it is ohms per unit length of the line, and shunt admittance, so Y equal to G plus J omega C. So in this unit is mhos per unit length of the line. So in the case of series impedance, the two parameters are considered. One is resistance and another one is reactance value. So for admittance value, conductance and acceptance value is taken. So angular frequency, so it is important parameter. It is measured as omega equal to 2 pi f. So it is calculated in radians. So next, relation to secondary parameters. So here we take characteristic impedance. So it is given by Z0 square root of Z by Y, and propagation constant gamma. So alpha plus J beta, it is related to square root of ZY. So we relate the secondary constants to primary constants. So where propagation constant is having two components. So since it is a complex value, real part is attenuation constant alpha, imaginary part is phase constant beta. So this propagation constant gives the parameters of propagation. So first of all, attenuation constant, it measures the attenuation of the signal as nappers per unit length of the line, And phase constant, it measures the phase changes, so radians per unit length of the line. We know that Z is R plus j omega L and Y is G plus j omega C. So it relates the secondary constants with the primary constants. So and then Y multiplied by Z naught. So this is the important relation. So we substitute the values for square root of zy into square root of z by y. So when we cancelling the terms of y, we get square root of z square, so it is z. So z is given by r plus j omega l. So it is important relation, and y by z naught we get as y, which is g plus j omega c. So we can summarize this topic. The four parameters of transmission line are represented as RL, C and G: resistance, inductance, capacitance and conductance. So they are used to find the properties of transmission line, and they are also called as the primary constant of the transmission line. And some of the conversions we use for solving the transmission line problems, which is rectangular to polar conversion and polar to rectangular conversion. So some examples are given. For in the rectangular format we have 4 plus j3 means here this real part and imaginary part is given for conversion as polar. In the polar form we have magnitude and then angle. So we can solve it using calculators also. And other arithmetic calculations used in transmission line problems. So addition and subtraction of complex values are solved in rectangular format, and multiplication and division of complex values are performed in polar format. So let's see an example problem. The characteristic impedance of a uniform transmission line is 2000 ohms at a frequency of 1 kHz. At this frequency, the propagation constant was found to be 0.054, magnitude and angle 60 degrees. So determine the values of line constants R, L, C and G. So this can be solved using previous relation, that is omega equal to 2 pi f. So using the frequency value we get omega, and then we have seen the relation between the primary and secondary parameters. So we get r plus j omega l, and by substituting the omega value we get the value of l. And similarly for g plus omega gc, we are substituting the omega value and we calculate g and c values. So let's take assessment. Which of the following parameter is not a primary one? So the answer is B, attenuation constant. The primary constant parameter that is associated with magnetic flux linkage, the answer is B, that is inductance. The primary parameter that is associated with electric charges, the answer is capacitance, so C. Leakage current is referred as the answer is conductance, C. The lines having RLC distributed along the circuit are called as, it is distributed, so it is B. So thank you for listening.